Download this code from codegive.com, link in the description below. OK, let's dive deep into the DEF error issue on Mahindra Bolero bs6 vehicles, specifically addressing DEF, diesel exhaust fluid, dosing malfunctions. This is a common headache for owners and mechanics alike. We'll cover the system, common causes, troubleshooting steps, potential fixes, and even some example code snippets, though code access is usually restricted. Disclaimer: working on DEF systems requires a good understanding of automotive mechanics and electronics. Incorrect diagnosis or repair can damage the system and lead to further problems. If you're not comfortable with these tasks, it's always best to consult a qualified technician. Also, attempting to bypass or disable the DEF system is illegal and harmful to the environment. Understanding the bs6 DEF system, selective catalytic reduction, SCR. The bs6, Bharat Stage 6, emission norms in India mandate significantly reduced levels of pollutants, including nitrogen oxides, NOx. To achieve this, Mahindra Bolero bs6 models employ an SCR, selective catalytic reduction, system. Here's a breakdown of its key components. DEF tank holds the diesel exhaust fluid, a solution of urea and deionized water, typically 32.5% urea concentration. It's usually located under the vehicle, often near the fuel tank. DEF pump module. This module draws DEF from the tank, pressurizes it, and pumps it to the injector. It contains the DEF pump, level sensor, temperature sensor, and sometimes a filter. DEF injector. Doser atomizes the DEF into a fine spray and injects it into the exhaust stream before the SCR catalyst. Precise dosing is critical. SCR catalyst. A honeycomb-like structure coated with a catalyst material, usually a combination of vanadium, titanium, and tungsten oxides. The injected DEF reacts with NOx in the presence of the catalyst to convert it into nitrogen and water, which are harmless. NOx sensors. Typically, there are two NOx sensors. Upstream NOx sensor, before catalyst measures NOx levels entering the SCR catalyst. Downstream NOx sensor, after catalyst measures NOx levels exiting the SCR catalyst. This data is used to monitor the catalyst's efficiency and adjust DEF dosing. Temperature sensors. Several temperature sensors are strategically placed. Exhaust gas temperature, EGT, sensors. Monitor the temperature of the exhaust gas before and after the SCR catalyst. Proper temperature is essential for the SCR reaction to occur efficiently. DEF temperature sensor. Informs the ECU about the DEF temperature, as DEF can freeze in cold weather, affecting its flow and atomization. Engine control unit, ECU. The brain of the system. The ECU receives data from all the sensors, NOx, temperature, pressure, level, and controls the DEF pump and injector to achieve optimal NOx reduction. It also monitors the overall system health and triggers warning lights and diagnostic trouble codes, DTCs, if a problem is detected. Heater system, DEF tank and lines. In colder climates, heaters are used to prevent DEF from freezing. These heaters are controlled by the ECU based on temperature sensor readings. Pressure sensor. Some systems have a pressure sensor on the DEF line to monitor the DEF pressure. 2. Common causes of DEF error on Mahindra Bolero bs6. The DEF error message on the Bolero's dashboard is a general indication of a problem within the DEF/SCR system. It doesn't pinpoint the exact fault, so further investigation is needed. Here's a breakdown of the most frequent culprits. 1. Low DEF level. This is the simplest and most common cause. The DEF tank is simply low on fluid. 2. Contaminated DEF * DEF is very sensitive to contamination. Using fluids other than genuine DEF, or introducing dirt, dust, or other contaminants into the tank, can clog the injector and damage the pump. 3. Faulty DEF pump module * the pump can fail due to wear and tear, corrosion, or damage from contaminated DEF. Symptoms include inability to build pressure in the DEF line, excessive noise from the pump, complete pump failure. 4. Clogged DEF injector, doser the injector's fine nozzle can become clogged with crystallized DEF deposits, especially if the vehicle sits for extended periods. 5. Faulty NOx sensors * if the NOx sensors are inaccurate or malfunctioning, the ECU won't be able to properly monitor the SCR system's performance or control the DEF dosing. 6. Faulty temperature sensors * inaccurate temperature readings can prevent the DEF heater from working correctly, leading to frozen DEF, or cause the ECU to miscalculate the required DEF dosing. 7. DEF line blockage / leakage * DEF lines can become blocked by crystallized DEF, especially in colder climates. Leaks can cause a loss of pressure and DEF consumption issues. 8. Faulty DEF heater * if the DEF heater fails, the DEF can freeze in cold weather, preventing it from being pumped and injected. 9. Wiring / connector issues * loose, corroded, or damaged wiring or connectors can disrupt the signals between the sensors, actuators, and the ECU. 10. ECU malfunction * in rare cases, the ECU itself can develop a fault that affects the DEF system's operation. 11. Software issues * sometimes, a software update or recalibration of the ECU is needed to resolve issues with the DEF system's control logic. 12. Exhaust leaks before SCR * exhaust leaks before the SCR catalyst can disrupt the proper flow of exhaust gases and affect the SCR reaction. 13. Catalyst failure * the SCR catalyst itself can degrade over time, reducing its efficiency in converting NOx. This is usually a longer-term issue. 3. Troubleshooting steps for DEF error. Here's a systematic approach to troubleshooting the DEF error on a Mahindra Bolero bs6. 1. Visual inspection *. Check DEF level * make sure the DEF tank is filled with the correct fluid. If it's low, top it off with genuine DEF. Inspect DEF tank and lines * look for any signs of leaks, damage, or crystallization around the DEF tank, lines, and fittings. Check wiring and connectors * carefully inspect the wiring harnesses and connectors associated with the DEF pump module, NOx sensors, temperature sensors, and injector. Look for loose connections, corrosion, or damaged wires. Clean corroded connections with electrical contact cleaner. 2. Diagnostic trouble code, DTC, retrieval * use a diagnostic scanner * connect a suitable OBD2 scanner, preferably one that supports enhanced diagnostics for diesel vehicles, to the vehicle's diagnostic port. Read DTCs * retrieve any stored DTCs related to the DEF / SCR system. Record the DTCs and their descriptions. Clear DTCs, temporarily after recording the codes, clear them. This allows you to see if the same codes return after further testing. Important DTC examples, common DEF / SCR codes. P20E8 * reductant pressure too low. P20EE * SCR NOx catalyst efficiency below threshold. P20F5 * reductant consumption too low. P2O4F * reductant system performance. P2BA7 * NOx exceedance, root cause unknown. P20BD * reductant heater control circuit low. U010E * lost communication with reductant control module. *P2047 reductant injector circuit open. *P2048 reductant injector circuit short to ground. *P2049 reductant injector circuit short to voltage. *P203D reductant level sensor circuit high. *P203E reductant level sensor circuit low. 3-component testing, based on DTCs. The DTCs will guide your component testing. *Def pump module testing *. Voltage check *. Verify that the def pump module is receiving the correct voltage and ground signals. Use a multimeter to check the voltage at the pump's connector with the ignition on. Pump activation test *. Some diagnostic scanners allow you to activate the def pump directly. If the pump doesn't activate, or if it makes unusual noises, it may be faulty. Pressure test *. Use a pressure gauge to check the def pressure at the injector. Compare the measured pressure to the manufacturer's specifications. Def injector testing visual inspection remove the injector and visually inspect it for clogs or damage. Cleaning if the injector is clogged, try cleaning it with a specialized injector cleaner or compressed air. Do not use sharp objects to clean the nozzle. Resistance test use a multimeter to measure the resistance of the injector's coil. Compare the measured resistance to the manufacturer's specifications. Activation test some scanners allow you to activate the injector. Listen for a clicking sound, indicating that the injector is opening and closing. NOx sensor testing live data monitoring use the diagnostic scanner to monitor the live data from the upstream and downstream NOx sensors. Compare the readings under different engine load conditions. Sensor comparison compare the readings of the upstream and downstream NOx sensors. The downstream sensor should typically show a significantly lower NOx level than the upstream sensor when the SCR system is functioning correctly. Wiring check check the wiring and connectors for the NOx sensors. Temperature sensor testing resistance measurement use a multimeter to measure the resistance of the temperature sensors. The resistance should change with temperature. Live data monitoring use the scanner to monitor the live data from the temperature sensors. Compare the readings to the expected temperatures. Def heater testing voltage check verify that the def heater is receiving the correct voltage and ground signals. Resistance check check the resistance of the heater element. An open circuit indicates a faulty heater. For def quality test refractometer use a refractometer to measure the urea concentration of the def fluid. The ideal concentration is 32.5%. If the concentration is outside the acceptable range, the def fluid may be contaminated. 5-component replacement, based on testing. Replace any faulty components based on the results of your testing. Use genuine Mahindra parts or high-quality aftermarket equivalents. 6. SCR catalyst inspection, advanced. Back pressure test A clogged or damaged SCR catalyst can cause excessive back pressure in the exhaust system. Professional evaluation if you suspect catalyst failure, it's best to have it inspected by a specialist using specialized equipment. 7. ECU REF lashing/software update, advanced. In some cases, a software update or recalibration of the ECU may be necessary to resolve def system issues. This requires specialized diagnostic tools and software, and is usually performed by a dealership or qualified technician. 4. Code examples, illustrative, access is limited. Access to the specific control code for the Mahindra Bolero bs6 DEF system is restricted to authorized technicians and dealerships. However, I can provide illustrative examples of the types of code used in these systems. Explanation asterisk. Asterisk sensor inputs asterisk the code reads simulated sensor values, DEF level, exhaust temperature, NOx levels. In a real system, these values would come from actual sensor readings. Asterisk control logic asterisk the code implements simplified control logic to determine the DEF flow rate based on exhaust temperature and NOx levels. Asterisk warning and activation asterisk the code generates a warning if the DEF level is low and activates the DEF pump and injector if DEF injection is required. Asterisk hardware abstraction asterisk the // code to activate the DEF pump and injector comments indicate where hardware-specific code would be placed to control the actual pump and injector. This code would typically involve interacting with microcontroller peripherals and using specific device drivers. Asterisk illustrative nature asterisk this is a highly simplified example and doesn't represent the full complexity of a real-world DEF system control algorithm. Real systems involve much more sophisticated control strategies, error handling, and safety mechanisms. Important considerations asterisk. Asterisk calibration data asterisk DEF systems rely on calibration data stored in the ECU to ensure accurate dosing. This data specifies the relationship between sensor readings, engine operating conditions, and the required DEF flow rate. Incorrect or corrupted calibration data can lead to malfunctions. Asterisk security asterisk access to modify the ECU software or calibration data is typically restricted for security reasons. Unauthorized modifications can have serious consequences. Asterisk diesel particulate filter, DPF while not directly part of the DEF system, the DPF is another critical component of the bs6 emission control system. Problems with the DPF can sometimes indirectly affect the DEF system and trigger error codes. Preventive maintenance. Asterisk use genuine DEF asterisk always use genuine DEF that meets the ISO 22241 standard. Avoid using contaminated or expired DEF. Asterisk regular DEF level checks asterisk monitor the DEF level regularly and refill it as needed. Asterisk avoid overfilling asterisk do not overfill the DEF tank, as this can damage the system. Asterisk proper storage asterisk store DEF in a clean, sealed container in a cool, dry place. Asterisk regular vehicle servicing asterisk follow the manufacturer's recommended service intervals for your Mahindra Bolero bs6. Asterisk address issues promptly asterisk if you notice any warning lights or error messages related to the DEF system, address them promptly to prevent further damage. 6. Seeking professional help. If you're unable to diagnose or repair the DEF error on your Mahindra Bolero bs6, it's always best to consult a qualified technician who has experience working on these systems. Dealerships and specialized diesel repair shops have the necessary tools, diagnostic equipment, and expertise to properly diagnose and repair DEF system problems. By understanding the DEF system, its components, common problems, and troubleshooting steps, you'll be better equipped to diagnose and address DEF error issues on your Mahindra Bolero bs6. Remember to prioritize safety and consult a professional if you're not comfortable performing the repairs yourself. Good luck.